Right, question 8. An archer lying down on a cliff elevated at 50 meter high from the ground shoots an arrow at an angle 30 degree above the horizontal with the speed of 80 meter per second. Okay, so what do we have? What information do we have? Okay, so this archer is lying down on a cliff, something like this, and then this is 50 meter, and then the archer is here. Boleh lah itu, they lie down. Okay, and then he shoots the arrow at an angle of, so this is the arrow at an angle of 30 degree, and then it has a speed of 80 meter per second. Okay, so the arrow would be going down, so our S is negative 50 meter. Okay, so how long does it fly in the air? Okay, so let's do that. So how long does it fly in the air is, we are only gonna look at the y component. Okay, so for the y component, we know that we can use sy uy negative half gt square. So this is projectile motion. Please look at the table that I've summarized in your notes. There's the formulas that I'll be using here. Okay, so uy, what is uy? Uy is 80 cos 30 degree. Okay, why do I use cos? Because the angle is adjacent to the x-axis. Okay, so this is, calculate this, you'll then get, I think it's 40 meter per second, yes. And then ux is just 80. Bongo niya, salah lah. Sorry. Sine 30 ba? Sorry, this is sine 30 degree, 40 meter per second, 80 yang cos 30 degree, which is, let me calculate, 80 cos 30, it is 69.3 meter per second. Okay, this is just the information lah. Okay, 80 sine 30 is 40 kah? Okay, betul. Okay, now let's look at the time of fly. How long does the arrow fly in the air? So we have sy to be negative 50. This is sy ya. This is sy. Why? Because dia sekarang berada di vertical. If x sx, it is at the horizontal. Okay, this is sx. Okay, now 50 uy is 40 minus half 9.81 ut. Hey, I keep forgetting t square. Okay, so here you'll get 4.91 t square minus 40t minus 50 equal to 0. Substitute this into your calculator, quadratic equation. You'll then get two numbers, one is positive, one is negative. Take the positive one, which is 9.23 seconds. Okay, so that is the time of flight. Next, how far from the base of the cliff? How far from the base of the cliff does the arrow fly until it hits the ground? Okay, so from the base of the cliff, it is here. Okay, it is not 50 meter bukan itu jawapan dia. We are looking at the horizontal. Okay, dia cakap dari this base here, ni base ni, sampai mana tu arrow pergi. Okay, so we are looking at the x component now. So x component. So x component, we know that acceleration is equal to 0, so we can use sx ux t. Okay, so this is easy. Ux is just 69.3 times dengan the time of the time of flight, the time of flight, which is 9.23. So you can just find you can get the why am I so blur? Okay, you can then get the distance to be 639 meter. Okay, so that is your horizontal distance, which is how far from this base of cliff does the arrow goes through. Okay, now the final question: calculate the speed of the arrow just before it hits the ground. Okay, now for this one, this is a projectile motion. So if it is a projectile motion, we have x and y component, right? So we have ux, which is 69.3 meter per second, and then we also have uy, which is 40 meter per second. Okay, however, we still have to find the magnitude. Okay, the magnitude of we have to find the final velocity. Okay, so this is ux would be equal to the final velocity at the x component, which is 69.3 meters per second. And then for the final velocity vy, there is acceleration at the y component, so it won't be equal directly to uy. So how do we find that? Is we are using this formula, vy uy minus gt. Okay, so from this we can then find the final velocity at the vertical component to be 40 minus 9.81, 9.23. So this is negative 50.55 meter per second. The negative is telling us the direction of the velocity, which is going down. Okay, so now we have to find the magnitude, which is square root of vx square plus vy square. Just substitute the values, calculate it, you'll then get 85.76 meter per second. Okay, so they are asked about the speed of the arrow. Speed does not have direction, so we can only stop till here, which is just the magnitude lah. Okay, but if it mentions velocity, make sure you include the magnitude as well as the direction, which is shift tangent to. Okay. Right, so that is your question number 8.